Hello everyone, in this video we are going to see about how to add two polynomials. First of all, we should know what is a polynomial, and then we should also know what is a linked list. We are going to use linked list in order to add the two polynomials. As we know that linked list is one of the data structure which is the secondary data structure that comprises of elements. And a polynomial is a mathematical notation where we are using the coefficient and the degree in order to mention a consecutive terms as a polynomial. Okay, so now let us see first of all how a polynomial looks and then how we are going to add the two polynomials. Here we can see in this diagram poly 1 is polynomial 1 and poly 2 is the polynomial 2. We are going to add these two polynomials. Let us see mathematically how to add the polynomials and then we go for the programs. Now here how to mention this mathematical equation in the computer memories. Here the given example 5x power 6 plus 6x power 4 plus 2x power 3 is one polynomial and it is represented as 5, 6 and then a gap, that is the node. This first box, a rectangular box, is a node which contains three compartments, where the first compartment is the coefficient and the second is the power and third is the pointer to the next compartment or the next node. Okay, so we call this the collection of nodes, and the nodes consist of three compartments. First is for the coefficient, next is for the power, and the other is for the next pointer which points to the consecutive pointers. And also we can see in this diagram the last pointer is given as white color, which is the end of the pointer. That means no more elements to add, that is a null pointer. Same way, and like 6 into x power 4 is given as 6 is the coefficient and 4 is the power, and it has continuous next term is also there, so it points to the next node. And 2x power 3 is given as 2 and 3 in the consecutive boxes, and the white pointer or the null pointer says that there is no more components for this polynomial. Same way, the polynomial 2 is also represented 8x power 6 as 8x and the pointer, and then 3x square as 3 and 2 then the pointer, and 4x as 4 and 1 because x power 1 is x, so 1 is the degree or power, so the next pointer is for the next constant which is 5. So 5 is actually x power 0, so the coefficient is 0 and it has the no more components, so it is given as an white color as a null pointer. So this is how the pointers helps to, and the polynomials are represented using the linked list concept. As we know that linked list is a list linked by the addresses. Okay, now let us see first the output, then only be able to follow the program logic. Okay, so we can see from the screen that enter the value of first polynomial, and actually how we have designed the program is we use 1 as the flag in order to continue adding the components. If you add anything other than 1, you take it as a 0, so that means the number of components you have added is enough in the polynomial. Okay, this is the way we have programmed this program, and the logic is programmed that way. So we can see here the first these are the output when you start executing the program. This is the way the output screen looks like. So here how to give the input is enter the value for the first polynomial, then we started, it is asking enter the coefficient, enter the power. So we are giving 2 and 2. This means the coefficient 2 and x to the power 2. So you can see the polynomial here, the polynomial expression is 2x power 2. Okay, likewise then the next point says enter 1 to continue. That means there are few more nodes are there, few more nodes in the polynomials are there, so we giving 1. Then we enter coefficient as 4 and power is 1, which says 4x power 1. We can see the extra term plus 4x power 1, and then continue by giving 1, enter 1 to continue. So now the coefficient are 6 and 0, which is 6x power 0, which is 6. X power 0 is 1, so 6. So the polynomial is 2x square plus 4x plus 6. Same way the next polynomial is given as the input. So 4 and 3 says that it is 4x power 3 and it continues by giving 1, and then 5 and 2 is 5x power 2, 5x squared is given over here, and same way to continue again for the next node. 10 0 means 10x power 0 is 10. Okay, so now after giving these two polynomials, the program adds these two polynomial and display the polynomial as the polynomial equation addition results is. So it is given as 4x power cube. How it is 4x power cube is, we have to always start from the polynomial with the highest degree, which is degree is the degree power. Okay, so 4x power 3 is the highest degree among the both the polynomials, so we have taken the first polynomial as 4x power cube. So that term has no similar term in the other polynomial, so you have to copy the 4x power cube as it is, then plus 7x square. So when you look for the x square term, first polynomial has 2 and second has 5. So 5 plus 2 is 7. So 5 plus 2 is 7. 7x square is the addition of the two polynomials. So the answer given is 7x square. And then we have to go for the x term. So x, only 4x is there in the first polynomial. So we are giving 4x as it is. That is 4x power 1 plus, in the x power 0 term we have 6 and 10. So 10 plus 6 is 16. So the answer is 16 into x power 0. This is how the polynomial is added mathematically and also using the program. Okay. Now let us see the program one by one, because the program is lengthier. I have given the program module by module in pages by pages. Okay. So now let us see first how the program starts now. So here include stdio.h, that's for the input from the C program, and then standard library stdlib.h for some library functions we are using in the program, and then we have struct poly. We are going to define a data structure called struct. Struct is the secondary data structure which is coined by the primary data structure, that is the primary variables. We are going to create a structure called poly. In that structure we are going to add two variables, int coef and int power. So these two are the components of the one node of the polynomial. As we are seeing the example, 3x square means 3 is the coefficient and 2 is the power. So we are giving two variables as a structure under the name poly, and then we are giving one more struct poly asterisk next. This is called as an self-referential structure. A structure is referred within the structure using the same name. That is called as an self-referential structure. That means this is going to continuously repeated for the continuous nodes of the polynomial. So we are using the struct as the keyword, and again we are creating poly. Poly is the name of the structure within structure. So structure poly space asterisk next. That means it is going to give the next pointer and add more and more components, more and more nodes to the polynomial. Okay, let us see with the diagram. It will be easy to follow. And now we are defined the structure. Now we are just closing the structure using the close bracket. So this particular part of the program defines a structure called poly, and the components are coefficient and power. Okay, now we are using the type def. Type def is the keyword which is going to define a structure and poly of poly. Now here these two poly are not same. This poly is the template or the blueprint, and capital P poly is the variable name used over here. So this type def is a keyword that defines a structure of polytype. And what is polytype? Polytype is again a structure. So it is a self-referential structure is created using this type definition keyword. And we are giving the value name as capital poly. Okay. So now we have defined the structure. Now we are going to use three functions in this polynomial addition. Create poly of list, void create poly list, and then void display poly list, and void addition poly 1, poly 2, and poly result. That means here we are going to create the polynomial using the function poly, and after getting the input or making the output, we are going to display the result or the input using this display program, the function. And void addition is the some function which is going to add two polynomials. What are they? Poly 1 and poly 2. Those poly 1 and poly 2 comes under the type poly, and answer is also is the same poly type. And what is the variable name? Result is the variable name. We are using the pointer variable to define this poly 1, poly 2 and poly 3, because you are going to use the linked list is the connection of the node by the memory address. So using the pointer variables. So till this part of the program, just you have defined the data structure as well as the function of going to use in the program. So now we can see 6 4, this is one node, and this rectangle next compartment gives the address for the next variable in the memory. Likewise it is continuing. Then we are having one more node called 2 comma 3. 2 is the coefficient and 3 is the power, and now it is darkened by the black, which means there is no more pointers, no more nodes, so it is a null pointer. This is how the linked list is mentioned in the computer memory. Okay, now let us see the next continuous functions, and before that we have to define the main function. What this main function is going to do? The main function just defines, first allocates the memory for this poly 1 and poly 2. So malloc is the inbuilt function which creates memory for the things within the braces. So what is the brace contains? Size of poly. So poly is the structured data type that contains two elements, coefficient and power, and for those two variables the memory has to be allocated. This is done by the malloc function for poly 1. Same way malloc of size of poly for poly 2 also we are creating new space for the polynomial 1 input and the polynomial 2. And now we are creating one more memory area for the result, because we are going to add and store in some other variable. So again the same function is used, malloc of size of poly. So this function creates a memory space inside the system memory. And now we say initially poly 1 of next is null. That means initially poly 1 is only a single node, is nothing is there, it is initializing, it is a null pointer. Same way poly 2 of next is also null. So initially poly 1 and poly 2 are null, nothing is there initially. We are going to keep on adding nodes and nodes according to the definition of the polynomial. And now we are going to get the polynomials. So how to get the polynomials? So here we are using the function create poly. Okay, so this message will say create poly, so we have to call the create poly function, and once the function creates the polynomial equation is printed on the screen. So print the polynomial equation is how it is printed using the display function. So display of poly 1. Same way the second polynomial is also received, print end of the value of second polynomial, and here create the polynomial 2, and then we are going to display the polynomial on the screen using the display poly 2. So these lines so far creates the polynomial using the create function and display the polynomial on the screen. And now we are going to call the next function addition of poly 1 comma poly 2 and put the result in result variable. So after putting this, result is also has to be displayed. So we have to again give the printf message, the polynomial equation addition is, result is. So it will display the result also. So far all the inputs are got and all the functions are called to do the respective functions. Let us see the functions one by one, and return 0. So this is the main program returning 0 to the operating system. So far the whole body of the function, the abstract is developed now. Now we are going to in depth find learn one by the functions one by one. Create is one function, display is one function, and addition is another function. Let us see the function one by one. So this is the way the create function creates the polynomial. So how it is created? Void create poly of list. This list is the one which follows the pointer variable from the poly as the variable which is get from the main function. Int choice. A choice is got, as we have seen earlier. If 1 is given, continuously the inputs are got. If anything other than 1 is given, the input is stop. So we are creating a variable called position and new node under the variable poly. Okay, and now we are going to just put the value which you got from the function that is given to the position. The list is stored into the position variable, and then you do loop is started. What does do loop says is do open braces new node is equal to m alloc of size of poly. This will create a, because every time you create a new node, memory area has to be allocated and that has to be attached to the list. So it is allocating compartment by compartment. So now this new node is equal to m alloc of size of poly. So this will create a new node, and then enter the coefficient. As suppose we are going to create this first node 6, 4, we will enter as 6. So once the coefficient is entered, we will ask for the, so this is the scanf statement to get the values. So percentage d is used for the integer variable and the values. So ampersand is the function, or is used to scan any variable name, and that is for that new node first we are getting the COEF, which is the coefficient. Then we are again printing the messages, enter the power, and this will scan of the power value from the ampersand new node of power. So now two variables, coefficient and power. In this example, first box 6 and 4 is got. Okay, so once it is got, we are just pointing to the next pointer. New node of next is equal to null. So now initially one node is created, nothing is added, so we are putting null. After that, what you do, position is of next is equal to new node, position is equal to new node. This will continuously connect the one node to the other node using the pointer variable. And now press 1 to continue. If 1 is pressed, we are keep on going to add consecutive nodes to the linked list. So that is got from the scanf percentage choice. So the loop closes by while choice is equal to 1. So if the choice is 1, we are keep on adding. If you don't want to add any nodes, we have to give 0 to come out, or any other value other than 1 to come out of this input function. Now this is about the create function. Next is the display function. What does the display says? Display is going to display the polynomial on the screen. So how it is going to display? The format is given over here. So seeing this example here, the display should be like 2x, that arrow, this cap and then 2. This is 2x square, likewise plus. So in order to get the display on this format, we are using this display function. So what does it do? Void display poly of list, open the brace, poly position, and then position is equal to list of next. Thus this will just go through the consecutive boxes, and while position not is equal to null, that means if there is no more null pointer is reached, you have to keep on display the polynomial until the null pointer is reached. So while position not is equal to null, open the brace and print of percentage d x this cap. This is for the format of this shown in the example here. Okay, so percentage d, the number is given, x cap, the symbol will come, and then percentage d next degree power will come, and then plus symbol will come. For this we are using this formatting statement. Okay, so once one node is printed, we have to go to the next line saying that position is equal to position arrow next. So this will point to the next variable of the polynomial, next node of the polynomial. And now we say how we have to stop. If position not is equal to null and position of coefficient greater than 0, that means if we are got all the nodes to display, that means if the position not equal to null and position of coefficient is greater than 0, that means you have to get all the variables which is greater than 0. Okay, so once it is got, we have to printf plus. So this printf, this plus will keep on putting one plus in between the different terms of the polynomial. So this is how the So now all the open braces are closed by the continuous 3 closed braces, and this function helps to display the polynomial on the screen. Next function is going to add the polynomials. How it is going to add and what it is going to add? Poly 1 and poly 2, and put the result in result variable. So open the function and you create a position as a new pointer, new node, and then you create one more new node under the poly structure, and now we are just initiating poly 1 is equal to poly 1 of next. That means we are just pointing the polynomial to the consecutive nodes. So now same it is done for the polynomial 2 also, and now we are going to check the result of next is equal to null. So initially set the result as null because nothing is done in the result now, only the poly 1 and poly 2 are input, so the result is now initially null. So how to form the result? We have to start the procedure. So initially you put the result into the position variable, and then we have to have 3 different conditions. Let us see one by one. While poly 1 not equal to null and poly 2 not equal to null, this means if there is something in the polynomial 1 and there is something in polynomial 2, because both have some, should have some terms to add. So this check is done by while polynomial 1 not equal to null and 2 also not equal to null, we have to start the procedure. So how to start? Open the brace and then you will create a new node because you are going to add and put it in the new node. So malloc of size of poly as done in the previous lines, and now we are checking if we are going to add the degrees. Okay, so when the degree has to be equal in order to add the two nodes of the to add the two terms of the polynomial. In mathematically the polynomial terms can be added if their degrees are equal. If there is no term with the same degree, we have to just copy the terms of the polynomial. So we are checking whether the polynomial 1 is power is equal to polynomial 2's power. If both are equal, we have to add. So how to add? New node of coefficient is equal to, we have to add the polynomial coefficient of 1 and the coefficient of polynomial 2 and put it in the new node, which is going to be result. And after that we are just adding the power to the new node of power is equal to polynomial power, because suppose if we are adding 2x power 6 and 3x power 6 means we are adding 2 plus 3 and then power is same. So power has to be attached using this power. New node of power is equal to poly 1 of power. And now continuing to the next variable, poly 1 is equal to poly 1 of next. So we are next we are proceeding to the polynomial next node of the polynomial. Okay, and now polynomial 2 is equal to polynomial 2, because we have to continuously go through all the nodes of the polynomial. So for polynomial 1 we are using the pointer next. Same way polynomial 2 also, once the polynomials terms 1 is considered, you have to go for the consecutive terms. For that we are using the next pointer. Okay, and now this is closed. So this is the case where both the powers are same. Likewise we will see two other cases where one power is greater than the other, one coefficient is greater than the other. So for that we are going to the next loop, which is the else if. So before that we will see the example here. So now the powers of x power 6 is same in this example the case. So 8 and 5 are added and 8 plus 5 is 13 and the power is same 6. So the answer will contain one term called 13x power 6. This is the one example for the equal degree of the equal degree or the power of the polynomial terms. Then the next case says that if the polynomial, else if polynomial 1 power is greater than polynomial 2. Okay, if that is the case, what you have to do? Again open the brace, create a coefficient for the new node from the coefficient of the polynomial 1, because polynomial 1 power is greater, and then we have to create a power node for the new node. So we are copying the coefficient and power from the polynomial 1, because we are now considering the polynomial 1. Okay, and then polynomial 1 is equal to polynomial 1 of next. What is this statement says is just you have copied the power of this polynomial, higher power, into the result, and then we are just moving to the next term of the polynomial, because we have to continuously add the polynomials. Okay, so this block is over. Then go for the other case where polynomial 1 power is less than polynomial 2 power. So the same procedure, now we are just copying the new nodes coefficient and power from the polynomial 2. Same thing here. Okay, difference is the value is copied from polynomial 2, and again the pointer is moved as polynomial 2 and to arrow next. So it is moving to the next point. So this block is also over. So far what you have seen is checking for the equal powers, add the values. If the power is lesser or greater, only copy the power and copy the coefficient of the polynomials from 1 and then from 2. Accordingly it is less or greater. So now we have come to the, so now the example case is here 6x power 4. This term is not in the second polynomial, just you have to copy the x power 4 term in the answer. Same way 2x power 3, it is not in second polynomial, so you have to copy the same. And likewise x power 2, 3 term is not in the first polynomial, so you have to copy the same. And plus 4x is also not in the first polynomial, copy the same to the result and finally finish. So what does it mean is this following these three procedures are the if blocks, the polynomial is added and the answer will be 8 plus 5, 15 x power 6, and then it will be x power 4 is just copied plus x power 6 x power 4 plus 2 x power 3 plus 3 x power square plus 4x plus 5. So this power will go in the down order or the decreasing order. So by this we are able to create a additional polynomial which adds the coefficient and the keeps the power. Okay, and now we have to go to the new node. So we are just moving to the next pointer. New node of next is null, and then we are creating a new node. Position of x is equal to new node. Okay, and then position is equal to new. So these three lines will create a new node in order to attach to the result. So it is closed now. So now we are going to start the next loop. While poly 1 not equal to null and poly 2 not equal to null. This means there may be some terms left out in polynomial 1 or polynomial 2. You have to copy those values into the result. For this while loop will help. For that, again create a new node with the malloc of size of poly, and then if polynomial 1 not equal to null means you have to add the content of the polynomial 1 to the result. So new node of coefficient is equal to polynomial 1 coefficient, and new node power is equal to polynomial 1 power. So which is extra in the consecutive polynomial. Something is left out in the polynomial 1, copy to the result. This is done by this line of statement, and then we have to increment the pointer. Poly 1 is equal to poly 1 of next. Same way, some terms may be left out in the polynomial 2 also. So we have to go for the next term. Like as I said before, here 6x power 4 is there, and say 2 power x cube is there. So we are just attaching to the result, and which is left out in the first polynomial. Same way in the second also you have to consider. So that is done by the following statement. So how it is done? Same way, if polynomial 2 is not equal to null, then you have to copy the coefficient of polynomial 2 and the power of polynomial 2 to the new node, and you have to point to the next consecutive nodes. Poly 2 is equal to poly 2 of next. So after pointing to the consecutive polynomials, now we are creating a new node, and from that node we are just putting those values which are created from the new node. So that means we are temporarily creating a new node variable to fix the coefficient and the power, and after that we are just putting the value from new node to the position. Position is the value of the resultant polynomial. So after finding out this, we are adding the pointer to the position, which is the new position of new node of next is equal to null. That means the new node is a fresh one, nothing is that is copied to the result polynomial. So the position of next is equal to new node, and then we are creating a new node from the position. That means these three statements will copy the new node to the position, and then this new node will be empty to add more and more content. So that's all. The next term is also checked. So this is how the polynomial addition is done. Okay, so as I have seen in the previous cases, how the input is given and how the output is got, and hope it is easy to follow. So carefully observe how the polynomial is done, addition is done in the mathematical way, and accordingly how the addition is done using the polynomial nodes in the program. Hope it is easy to follow. Though it is a lengthy program, the concepts are simple and easy to follow, and thanks for watching.